Hello, time for the vibes of the universe. In my previous movie I was talking a lot about the atomic oxygen and how it affects the environment. I told you as well that those particles stopped freaking out and behave in a more rational way, where the main density remains on the day side of Earth. But this statement is not valid any longer, as on 26th of November, atomic oxygen began to freak out again. Most of those particles moved again to the night side. And something what I didn't notice before. During the time when atomic oxygen remains on the dark side of planet, it is visibly connected with the temperature of neutral gas in the ionosphere, which visibly drops when things are getting wrong. I'm not 100% sure, but I've probably managed to find some information regarding the disappearing particles from the current rings. During 25th and 26th November, there were 3 visible particle outflows. It can be just one of those famous coincidences, but right at the times of those 3 events, the density of electrons in the F2 layer of ionosphere was visibly growing. I think as well that the discharges of current ring are connected directly with the angle at which the equatorial flux tube connects itself to the planet. As you can see, after the discharge, the connection point was established in different part of the globe. After the second discharge, the direction changed as well. And now I'm not sure if the angle and discharges depend on the magnetic orientation of the IMF or if they are connected with the process visible on ionosphere monitors. Both options are possible and I need to make more research to learn more about it. Just as I need to research deeper the backside gusts of neutral particles, which I was showing you in previous part and which are still taking place while I'm recording this movie. For now, I'm capable to say only that those gusts affect the energetic particles trapped within the inner magnetosphere and cause visible compression of the plasma sphere. But for now, a small glance at the progressing anomalies of ionospheric currents. It seems that the electron cloud still wants to become vertical to its current state. It seems that in the beginning of November 27, Earth was hit by something pretty dense. The amount of spikes allows me to guess that it is a frontal density wave of incoming coronal host stream. More important is the fact that the incoming wave has different magnetic orientation than the environment in which Earth remained in last days. Phi angle shows that we just entered negative part of the IMF. Thankfully, CCMC started to update the SWMF plus RCM monitors, so now I will use one of them to show you the impacts of density spikes on our magnetosphere. Anyway, I can use the fact that Earth moved to another sector of IMF to see how the changes of magnetic components affect the connection with low energy field. One of the problems which I was talking about earlier. Just as I was expecting. When the orientation of solar wind changed, the equatorial flux tube connection was clearly affected. Before, the angle of connection looked like this. After the sector boundary crossing, the connectivity point shifted to western day-night reconnection area. However, this shift wasn't connected with discharge of particles. This means that I still need to wait with some final conclusions. But there is one more thing which is worth to be noticed. After Earth moved to a part of heliosphere with negative current flow, the equatorial flux tube connection became much less stable and started to rotate together with the planet. But low energy field is not giving up and continues to send particles which visibly prevent the tube to move further into night side. It is clear that the Earth low energy field connection is much weaker when the IMF has negative polarity. Before I will move further, I would like to show you another example of geomagnetic depolarization. Positive ionospheric potential is only partially located over the polar cap. The rest is visibly placed on the equator. Luckily, the differential is rather low and the negative charge is dominating. It seems that not so long ago a miracle took place. The OMNI solar wind data was at last updated, and I can turn on the simulation of magnetosphere in Visbart. Maybe some of you noticed already that I'm trying to look for any sign of order in the apparent chaos which surrounds us. That's why I'm interested in all kind of patterns and frequent events which can be predicted. And it seems that this time I've managed to catch a bigger fish. But before I will start to explain the details, couple words for those who don't know anything about the magnetic field of our planet. This is how the magnetosphere is supposed to look like. Magnetic field lines are here perpendicular to the equator. And sometimes we can actually see such shape in the simulation. Of course, we need to keep in mind the deformation caused by incoming solar wind. But sometimes doesn't mean always, because most of the time the shape and behavior of our magnetic field can differ quite a lot from that theory. It's easy to get lost in all those colorful field lines, so I've marked one of them to make it easier for you. It's a closed field line, as it connects both magnetic poles, just like those short lines from the image, which were perpendicular to the equator. This one is rather parallel than perpendicular, and it is stretched so much that it reaches to the magnetopoles. Such shape is currently much more common. And this situation changes quite a lot. First of all, closed magnetospheric field lines are responsible for the shape of plasmasphere, radiation belts and current rings. To demonstrate nicely, I will use another of my new toys. This one is called simply 3D view. Problem is that I still don't know how to use it properly, and the simulation is not connected with satellite solar wind data. To say it shortly, those field lines are pre-generated and show how the magnetosphere is supposed to look like, not how it actually looks. And now I will add one feature which you won't find in this board: simulation of plasmasphere. As you can see here, the shape of torus doesn't fit into the borders described by closed field lines. White line shows the magnetic dipole of pre-generated field lines, while a red one shows the geomagnetic axis for simulated plasmasphere. Now the belt started to fit into the field lines, as the angle depends on the planet rotation and dipole tilt. But now try to guess how the plasmasphere looks like when closed field lines are tilted towards the main geomagnetic axis, just as in this situation. Of course, it's just my private guess, but this is how I would see it. Such big tilt in the orientation of geomagnetic field is causing another problem: dislocation of polar cusps. Polar cusps are the weakest areas of magnetosphere, two holes in our magnetic shield which allow solar particles to enter the ionosphere and cause auroras during geomagnetic storms. Normally, field lines which create the cusps are connected to our magnetic poles. However, the time in which we have opportunity to live can't be called normal any longer. Southern cusp covers more than a half of the entire magnetosphere day side. At the same time, north cusp has clearly shifted to the night side and became much thinner. And when we will look from different angle, we will easily notice that the north cusp is actually divided. One seems to be connected just a little bit north from Norway, and second to northern Canada. Of course, it is caused by the fact that our planet is actually a magnetic tripole, but it is not the first time when I'm telling you this. I have to finish this movie, but I can't dismiss the class as I didn't even start talking about the main subject. So, be safe. Peace.